Okay, so big week, everybody, but we're almost done. So everybody has their practical this week, but we also have exam 4 to review for. So hopefully everybody is aware our 4th exam is on Wednesday. So on Friday, we'll be reviewing for our final. And we'll try and narrow in on the most important topics on Friday to condense some of that material a little, because it will be cumulative. I know we've been through a lot this semester. So let's do a couple review questions for exam 4. Okay. Let's see. Can you hear me now?
Yep.
Awesome, thanks. Okay. So we've been doing a lot of review of our heart stuff. So I want you to remember that we are going to go back to our muscle fibers. So do make sure for Wednesday to study different types of muscle fibers and their different kind of sources of energy for different types of exercise. So that's what we're going to drill a little bit today. Chapters we go over? I believe I know chapter 13 was one of them. Let me check. If anybody else remembers which chapters it was. 12 and 13. Okay, great.
Are you going to open up all of your slideshows?
Are they not open?
For mine, I don't know if I'm just looking in the wrong spot, but like for mine, I don't only show the unit level.
Okay,
So
yeah.
It's probably just mine.
No, I'll go back and double check. So those have been closing progressively.
They just like don't show up for me.
Okay, I'll check them and if not, I'll just leave them out. All right, so let's take a look. So one of our comparisons that we're making is just whether we are thinking about glycolytic fibers versus oxidative fibers. It's not the same as usual. I guess it now pulls me into here. Okay. How did we do? Okay, great. Yeah, our glycolytic fibers fatigue quickly, as our oxidative fibers, because they can use oxidative phosphorylation and the electron transport chain, fatigue slowly. Like their new method. doing? Great. Yeah, our fast oxidative fibers are the ones that are intermediate between our two other types of fibers because they have some fast qualities like our fast glycolytic fibers, but they have some oxidative qualities as well. You know what? If they're going to pull me into pull everywhere, we're just going to open that directly. Great. Yeah, our fast glycolytic fibers are the ones that are white in color. What molecule is responsible for making fibers red? So what molecule is absent here in the fast glycolytic fibers? Exactly, it's the myoglobin. While I'm standing here, someone remind me what myoglobin does? What is it storing?
Oxygen.
Exactly, oxygen. That's why we have it in our other ones. Okay, yeah, great. So our fast glycolytic fibers are the greatest in diameter because we don't need oxygen to diffuse across that membrane. So let's think about energy sources. Okay, so our primary energy source at the beginning of exercise is creatinine phosphate. So we just want to remember that we have that on tap for ATP right at the beginning of activity. And then our fibers are going to stabilize into either anaerobic glycolysis or oxidative phosphorylation. And with fibers, and link up these fiber types with motor units and order of recruitment. You can probably get to this answer either by remembering motor units or just the memorization of that chart of fiber types. Great. Okay, yep, great. Our slow oxidative fibers are going to be our smallest fibers. They're going to be found in those small motor units. So they're recruited first because we go small to large. Okay. Do it. Yeah. Okay, so the fast glycolytic and fast oxidative fibers can be converted into each other depending on what type of exercise you're doing. Why is that? What is this fast twitch fiber? What do these two types have in common? What's that thing that we can't change? Yeah, the myosin ATPase is the one thing we can't change. Otherwise, we can change cellular machinery. We can change number of mitochondria, things like that, but we can't change what chemical is inside them. So honestly, everyone seems like you're doing pretty great on fiber types, which is awesome. I'll make sure to put those on there. So if you're feeling a little shaky on these, remember, you can think about the function of each of these types of fibers, which I do recommend because that way it's less memorization. But if you're struggling, you can straight up take this table and memorize it. So we're gonna do a call and response thing, I guess. So I'm gonna highlight one part of this table. We're gonna wait 5 seconds, and then you guys are all gonna say the answer out loud. Let's see. Okay, so starting with this first one. All right, high or low? Great. Okay. Now next one, glycolytic capacity, high or low? Ooh, yes, low, great. Okay. Speed of contraction. Perfect. Myosin ATPase activity. Go. Yeah, low. All right, it's low, so that's why this is slow. Okay. Many or few mitochondria? Yeah, high mitochondrial density, many mitochondria. So capillaries. High or low capillary density? Yep. Oxidative, we need oxygen. All right. Next, myoglobin content. Perfect. Yeah. Resistance to fatigue. Yep, great. Okay. Fiber diameter. Perfect. Motor unit size. Small, yep. So finally, force generating capacity is, yeah, small. So because these fibers are narrow, they're small in diameter, that means we don't have as many myofibrils in a row, not as many sarcomeres, not as much force generating capacity. So you guys can do this on your own and go through the other two types. Seems like people are pretty happy on this. I don't have a lot of structure for today, mainly because we kind of blasted through my heart review materials on our past days. So does anybody have any questions or topics that they want to kind of revisit at this point? Up to the floor. Yeah, absolutely. When we're thinking about those Starling curves, we're thinking about the relationship between our EDV, right? So our end diastolic volume and our stroke volume. So when we're looking at these two things, the reason we have these curves is that we're going to put the sarcomeres in different sort of straight, different amounts of stretch, right? And so what we want to remember for these is that the optimal state of those sarcomeres is a little more stretched out than the normal size of the heart. So as we expand our heart, as we put more blood into it, and therefore as we increase our end diastolic volume, our stroke volume goes up because we're getting closer to that optimal point. So this overall curve is just a way we could look up what we expect our stroke volume to be given an end diastolic volume. So we see this increase in stroke volume as we go up, and it has this sort of characteristic curve shape. So then we think about these as families of curves, these Starling curves, because we can either shift this line up or shift this line down depending on our nervous activity. And so all that means, right, is that as we increase sympathetic activity, right, the same end diastolic volume will give you greater stroke volume, basically because we can think of these effects as kind of additive, right? We know that sympathetic activity increases stroke volume for a lot of reasons. And we know that that end diastolic volume has this effect on stroke volume. So we're just shifting it up. So we're layering kind of the effects of the sympathetic activity on contraction of those fibers, along with the effects of increasing end diastolic volume. So we could, we would only expect to see these families of curves with our sympathetic activity and not our parasympathetic activity. Does someone know why that is?
Sympathetics don't connect to the
They're,
ventricles.
yeah, exactly. They're not affecting the ventricles, so they're not affecting the contraction of those ventricles. So we'd kind of just sit at the one curve for the parasympathetics, right? So we're not going to expect parasympathetics to be affecting that stroke volume. They're affecting the heart rate, and that's how they affect our cardiac output. More questions about this or other things? I can put one up. Are those helpful? Okay, yeah, okay. I'll make one for you this afternoon then. Yep.
Remember the day that we went over like all the charts? Like
Which
I know
charts?
it's a very big question. About like the different stages of cardiac.
Maybe, and also have them all in order. So like when we went through all these pieces of that.
Yeah, could you run back to that?
Yeah, sure. Maybe we'll just make this picture big and kind of go through it as we do this. thought it was. All right, yeah, we'll just go through them. Okay. So, lots to zoom in on this. Just pick a new slide for this. No, that's fine. It's just we're not going to be able to see any of this stuff if it's not a bit bigger. I mean, and we could just go through all those slides, but it'll be better this way. Okay, so when we're thinking about those phases, the first thing we're thinking about is just what's happening with the heart. So where our blood is flowing, right? So for phase one, what's the name of phase one? Yeah, our ventricular filling. So we'll expect to see blood moving from the atria to the ventricles. So later down in this chart, we'll have a picture of the pressures, but where would we expect the high pressure to be during this phase, if that's the direction of the blood? Yeah, high pressure would be in the atria. And what's the state of our valves going to be? Yeah, our AV valves specifically are going to be open. So then our next phase, right, is our isovolumetric contraction. So we have blood moving nowhere, but we are starting to contract. So we're starting to create greater pressure here, but it's not yet greater than that in the aorta or in the pulmonary trunk. So all our valves are closed, our AV valves, our semilunar valves. That's why the blood's not going anywhere, but it's starting to push into the arteries. That's the beginning of systole because our ventricles are now contracting. And as systole continues, eventually we reach a point where the ventricles have higher pressure than the arteries that are going into. So those semilunar valves open up. The AV valves are still closed. Oops, sorry, looking at this image. Then we move back into diastole. So those ventricles are starting to relax. Right. So as we start to relax, we can see some blood starts coming in again, especially into those atria. Right. As we're relaxing everything, we're having blood starting to return to the heart. And then we loop back to our next phase. Our beginning here, the end of diastole is still phase one before we go back into systole. So that is the basics behind the rest of these parts of the table.
You said that systole starts with the ventricular contraction.
Yeah, systole starts with the isovolumetric ventricular contraction. So all systole is that heart muscle is contracted. Those two words, systole and diastole, are just contraction versus relaxation. So if we're looking at these graphs of pressures, like they can look a little more overwhelming, but really they're just summarizing those things that we already know need to be true based on what we know about what those chambers are doing, right? So we know that for those ventricles to fill, during that first phase, the AV valves have to be open. We don't have pressure in the ventricles. So those semilunar valves, the aortic and pulmonary valves, are closed. And we can see this in the pressures, right? The atrial pressure is high, which is why the blood is moving into the ventricles, because that's lower. Okay. And then as we enter systole, we start to do that isovolumetric ventricular contraction. We have that ventricular pressure shooting up. Our AV valves close so that the blood doesn't backflow into the atria. And once we raise our pressure high enough, it opens up our aortic and pulmonary semilunar valves. That's when we start to have volume in the ventricles go down because the blood is leaving. So we also then see our pressure in the aorta starting to fall as we stop shooting blood in these final phases. And what do we have at the bottom here? So the heart sounds and the ECG at the bottom are how we might measure these different things. So remember the heart sounds, what do they do to, what's happening with those heart sounds? What's creating that noise? Yeah, it's the turbulent blood flow. So that sort of waves crashing against those valves as they close. So it's happening while they close, but the noise itself is not like the valves clapping against each other. It's a noise that the blood is making. And that's why when we hear abnormal heart sounds, we hear like a swooshing noise potentially. So if it was just the physical valves like hitting each other, that kind of wouldn't make sense, right? Like what you're hearing there is differences in the blood flow and how that blood flow is not normal. And then we have our ECG, which tells us about those conduction events that are happening, right? So we can see the atria contracting, we can see the ventricles contracting, and then we can see going back to normal before our next state, basically. So what's going on here in that curve. Is that kind of what you were going for?
Yeah, it was just that middle one there with everything on top of each other that just.
Yeah, and I might even have been pointing to the wrong curves while we were looking at this. This one requires some careful reading, basically. So, but all it is sort of conceptually tracing what these pressures are. The pressure of the atria, the pressure of the ventricle, and the pressure of the aorta. The only thing I might ask you to calculate is not the cardiac output. So I might ask you if cardiac output would go up or down. But when we were calculating our stroke volume, that one, you might have a basic calculation, something like that. We don't really need to know about that for our purposes. Yeah. But yeah, that is just the blood just trying to sort of backflow a little bit. I'm gonna hang out, but why don't we just do some open study time? I know you guys have your practicals this week too, and I'm sure that's intimidating. So study for whatever you want. I'm gonna hang out, answer questions. But
Like the most confusing topic for students, or like which section of this seems to get people tripped up on. So
people have trouble with the valves. Yeah, and I think just kind of tying all these things together, I think you're right about coming back to this table with the cardiac cycle, because that kind of loops together the pressure stuff and the blood flow. Sometimes people get the order of those chambers and blood vessels wrong, and that really trips you up for everything. Because if you don't know that order, then you're not going to be able to pair conceptually which of those events has to happen next. Does that make sense? Yeah. So that's kind of like our baseline, and it is more of an anatomy topic than a physiology topic. It's just you can't do any of the physiology without it. But the adjustment of the cardiac output stuff will be really important for next semester. So that's really important to drill down, because I do find that by the beginning of next semester, people are again confused about cardiac output, which makes it difficult to understand like blood pressure.
From this semester to next semester, do you normally do a quick overview of it before we dive in?
A brief overview, yeah, but we do expect you to, have mastered this content before we move on to the next stuff.
Oh my gosh, yeah.
Left this week.
Especially this hundred thing. That seven. The alien piece. Yeah. That is an issue. That I got like a good question.
Final stretch. Yep. Yeah. I mean, we've gone through almost all the muscles in the body at this point. Yeah, so we'll be doing like sensory organs, so eye, ear stuff. I think that's what we're going to start with. And then heart, lungs, and GI system and reproductive system. Yeah.
What do students tend to struggle with more? Is it like this first semester or does second one get
I guess that's a little hard to say.
If we pass this one, can we pass the next one?
I think so, yeah.
I need that optimism.
Yeah.
Is it like when we go through the systems, is it like the systems as a whole, or are we gonna go like super in depth with like the cellular, like alveoli?
For lecture or for lab?
Oh,
We'll be talking about alveoli and stuff in lecture, yeah.
right.
And like gas pressures and
Right.
stuff like that.
Are we gonna go into like the super like in depth, like in the weeds, like why oxygen is exchanged with the alveoli, or is it like you breathe in oxygen and it goes into the alveoli?
We'll be looking at like partial pressures and how the air mixes and how that changes partial pressures in the blood and things like that.
Great.
So I don't know if that counts as in the weeds or basics for you.
This is like, that's the stuff that we learned when I was in my medic training.
Mhm.
We went through like anatomy 1 and 2, like within the matter of like a week and a half.
Yeah,
We were there.
rapid fire.
Yeah.
Uh,
So I was just kind of wondering like how, like,
Yeah, I mean, it'll probably be more detail, right? Like we're doing a full year on this stuff versus a week and a half. I can't imagine covering this all in a week and a half.
This is like a lot to take in.
Like going through the whole heart, that whole heart section was like, kind of like a review.
Yeah, yeah, because that's important.
Yeah.
Yeah.
So it felt nice. to
Good.
have that.
Good.
So I was just wondering if the rest of the systems were gonna be kind of like that. We went more in depth with the other systems than we did with.
Yeah. I think of the systems, I would say like GI is easiest and most kind of like surface level. We do go pretty in detail in respiratory specifically.
Alright.
Yeah.
Do you know, are you gonna have your next class for to be in a room like this, or is it gonna be like a generalist lecture?
You know, it's a great question. Let's see what room they assigned me.
I think that I was sending up, I saw that there were like some people or something.
Really? I don't think that's true.
Wrong about it.
I thought I had like 20. It shows you seats left rather than seats
Yeah,
filled. So where am I?
okay.
Yeah,
Good.
yeah, there are like 20 of us.
Yeah.
That was in 21, 22, but is that the science lecture hall? If we're in a big room, I'll get us moved to a smaller room probably, because I think 1109 is small and it looks like Dr. Eater has a big class again. She's not going to fit all those people in 1109. I know that for a fact. So we'll probably be there.
So do we have a physiology lab for AP2?
You do. It's a research project. So you're split into groups of like 4 and you come up with a question on the first day and then you collect data and eventually present it at the end. But
Why not?
so the things to remember for that one are do come to class and Dr. Schlater is going to give you a schedule on the first day of like what's due when and what quizzes are going to happen when. And people often don't read that schedule and are caught by surprise because it's not the same structure, you know, like a quiz on the previous time every, you know, morning, because since it's based around a research project, it just kind of doesn't make sense to do it that way. So people get kind of surprised by the fact that there's a quiz on how to use Excel and it is on that schedule. But if you don't look at the schedule, that can catch you off guard.
How many seats are available still? Like 52 out of 75 seats still available?
Yeah,
Oh.
yeah, so we have a small class. Yeah, so I assume it's the same group of us, just plus a couple more.
I don't know.
But yeah, I think Phys Lab, the second semester is pretty easy.
Do we still get like the fluffy Phys lab points, like 10 points? You know, to just like kind of boost your grade.
I seem to remember I handed out a lot of 100s last year, but I don't remember exactly how they were. I will say Dr. K is new, so I do not know what he will do if you're in his lab. So it's either Dr. Schlater or Dr. Kobayashi, and
Oh, that's right, we don't get to pick, you just get put in the right. Well, you
I
pick your
think they're
lab.
currently just like, yeah, I think they've just currently put Lindsay as the person for all of them.
We'll have
So
practical for-
there will be a practical for anatomy next time too. I imagine the people's lab schedules will probably stay mostly the same, but I don't know if that's the case. Currently, Dr. Schlater does the Tuesday labs and Dr. K does the Thursday labs, but we haven't had a meeting about that.
So you're sticking with just the lecture. So.
I've been teaching some anatomy labs this semester, but in the spring I won't be because I'm teaching a plants class as well.
Well, I would
be
be
fun.
fun. Biology.
Yeah. We're gonna go like snowshoeing and look at trees and eat Chinese food and identify what type of plant broccoli is.
I think one of your classes that-
And hang out in the
we didn't get that
greenhouse.
That sounds incredible.
I mean, I haven't taught it before, so hopefully it won't be too much of a mess, but I'm really excited. I always feel bad for you guys because like I know you have to take this class and you have to do well in it. So I'm also
Well, I mean,
excited to
we're
teach a
gonna be
class
doing-
where like, you know, people are taking it for fun,
They don't
kind of.
like you in dread.
Yeah.
This is my favorite class. I love this class.
Woo, that's awesome to hear.
I think microbiome is my favorite.
Oh, that
Real?
class
Cool.
made me cry. That one was bad.
Did you just say for real? Yeah, I like that.
Yeah,
Have you
just
taken-
like it.
Have you taken statistics yet?
That's this summer.
Not like
Thank
that.
goodness my best friend has her master's in math,
Mm.
so.
My statistics teacher is in Texas right
Oh,
now. Well, he like lives down there. so it's like-
Huh.
It's online.
are you taking it here or somewhere else?
Yeah, I'm taking it here.
Who's your professor? I
Robert Sherry.
have no idea who that is.
Probably because
Interesting.
he lives in Texas.
Yeah,
Yeah.
probably. I wasn't aware we could do that. Maybe I'll move to Hawaii.
It's a really boring statistic.
Statistics.
Yeah. It's like you're going for nursing, and it's like,
But it counts as what, is it like a psychology class?
yeah.
Yeah.
Probably because it messes with your head so much.
Probably. You know, I think I figured out why it's in the psych department over the summer, because it was in a psych department in my undergrad too, and I did not understand that. But over the summer, I had my research students and we have like seminars on Thursdays or something with everybody's research students together. And for the statistics one, I offered to lead it for some reason. And I was wandering the hallways asking people what statistics they use and like, if you can set up your experiment, like, and you can really control everything, like everything's in a petri dish or whatever, you don't have to use very complicated statistics because you are controlling so many variables. Whereas when you're doing something observational where you can't control like what people are doing, how they're responding, and you know, you can't control their educational background or their childhood, whatever, you have to get much more complicated with the statistics because there are all these sort of random factors that you could look at and can't control and are even sometimes quite hard to measure. Yeah. My stuff also involves complicated statistics as I am also observing people. But I was really jealous walking around the hallways being like, yeah, we run some t-tests.
They don't make us take like calc
Yeah.
and all these other subjects, take them again.
Yeah, there's a class in the math department that I know bio accepts as a statistics credit, which sounds really cool. I don't know if it's hard or easy, but it's like kind of project based and you do some programming around a project to learn the statistics. And that sounds like it would be more interesting and more fun than like memorizing a bunch of formulas to me. I mean, I don't know that that's what you do in your statistics class, but like
No, that's-
when I took statistics, that's kind of what it felt like. It's just memorizing a bunch of terms. I mean, I realize anatomy is like that too often, but.
I made a mistake. I didn't take anatomy in high school.
Mhm.
So like this is my
Wasn't
first.
even offered in my high school.
I didn't take it till grad school.
Didn't take any anatomy classes until graduate school.
Yeah, my first anatomy class was in a medical school with medical students. It was rough. I cried for like 3 hours a day. Started therapy for the first time in my life. But I know it now.
Some of this stuff with anatomy, like the points at a muscle, I hate it. Like I read it tomorrow. I'm
Yeah.
just banking on the fact that it'll be done and over with and I can put it in past.
Yeah.
I'll make it on
I
that.
know. I know I to switch to nursing, so not too far in the past.
I think it's better if you can spend more time on like why you care about it or like what it does. Because like it is really important for like as a nurse, right? Like when people come in and point out, they're like, I don't know, like I fell and now this part hurt, right? Like that's,
And I'll be like, oh, is that your toe?
your physiology is not going to help you, right?
Yeah.
But to learn all of anatomy in 10 days
10
in the lab
days.
is just
And good.
insane, and we don't have time to go over that
I think
stuff.
that's the issue sometimes.
Yeah.
It's just an overload. You go in there and you take a test and you're in that mindset and then all of a sudden you
Yeah.
flip to learn.
Yeah, and honestly, the thing I think that's absolutely most important in there, we've only been putting like on bonus questions. It's only on there at all because I insisted, because it's the most important thing, is like that anterior, posterior, and movements and stuff, because like you're not going to remember where every single structure is, right? But when you ask someone, they're going to say, oh, it's anterior to the blah, blah, blah. So if you take one thing away from anatomy, like
I feel
Got
like I
it.
would know if there was a good thing.
Oh, yeah, like,
Or like,
the structures, yeah,
oh, yeah.
possibly, probably. And there's technically a word bank, right? Like it's your giant sheet of terms.
yeah, about 6 of them.
Yeah.
Interesting, I thought about that, like, they don't have to do like multiple choice to make it easier, but if there's like a word bank, I feel like we would be successful. Maybe.
I think there's like 500 words in it, like, I don't care. Like,
Yeah, give me like something and I will go through the entire list and I'll probably come up with the right answer. Because the spelling is like
Oh,
tricky
yeah.
sometimes too. I'm like, if I can't pronounce it, I don't know how to spell it.
Mhm.
That's another issue.
Or the ones that are like posterior, superior, iliac, spine, or like.
They're about this long. and it's
Yeah.
like,
Like I said,
Why are there
super
6
helpful
words?
if you know what posterior, superior, whatever means. Yeah.
about 6 terms that start with the same like prefix.
Yeah, well, you should just start taking Latin in your free time.
Free time, what is that?
That I did take.
Yeah, knowing the actual meaning of the word instead of just like this word is that.
Mhm.
Mm.
can help you figure out.
Have you taken Latin?
No,
Oh,
but
I was like, did you take Latin? So now you just like
Some,
know them?
yeah, some of them are related to like vocabulary words in English.
like, I don't know, we just had to memorize so much in a short amount of time that was like, got a lot better at memorizing.
Yeah.
We went through like this semester course in 6 weeks. So,
Yeah. And honestly, I kind of suspect that's why they have a structure this class the way they do, is because like it's not like nursing classes get easier as far as I can tell. I mean, I haven't taken them, but like but I don't hear that they're super easy.
I hear that anatomy 1 and anatomy 2 is the hardest.
Yeah.
Yeah, that's what I've heard is that it's like a make or break class. Either you're gonna pass it and do fine, or they wean you out.
Yeah.
Which fair enough, because if you can't tell what's going on.
Yeah. That's why I struggle with it as a professor too, because like I do love this stuff, right? I just
I feel like every class I have more. I'm just
yeah,
take.
that is true. You should take fewer credits.
I forget. They're taking like ridiculous.
Yeah, I'm taking 23